Question 3 tells us that nitrogen gas reacts with oxygen gas to form nitrogen monoxide gas. So we need a balanced reaction. Nitrogen gas reacts with oxygen gas to form nitrogen monoxide. So that's just going to be a 2. Calculate the KEQ for this reaction if the equilibrium concentrations when 1 mole of nitrogen and oxygen is placed in a vessel and allowed to reach equilibrium. Once the reaction has reached equilibrium, the concentration of the nitrogen monoxide is 0.00365. So this question gives us initial concentrations for the nitrogen and the oxygen, and it gives us an equilibrium concentration for the nitrogen monoxide. So we need a rice table because we need the equilibrium concentrations for nitrogen and oxygen. It tells us that our initial concentrations for these are 1.0, and we start with 0 products. So we're going to minus x here, minus x here. We're going to plus 2x. That means this is 1.00 minus x. This is 1.00 minus x. And this is 2x. Now remember, it tells us up here that at equilibrium, the nitrogen monoxide is equal to 0.00365. So that means 2x is equal to 0.00365. So that tells us that our x is, whatever that is, divided by 2. So x is 0.001825. So now we can get our equilibrium concentrations of nitrogen and oxygen by doing 1 minus that value. So these are 0.998175. I will worry about sig figs later. Oops, that's not a 0, 0.998175. So now we're going to write an equilibrium expression. We always write an equilibrium expression so that we don't make any mistakes when we plug values in. So we have NO concentration squared up on the top, concentrations of N2 and O2 down here at the bottom. So our KEQ down here is going to be equal to 0.00365 squared divided by 0.998175. And we could either just square that or just write it out again. And so I'm going to take my 0.00365 squared. I'm going to divide it by 0.998175 divided by 0.998175. And I get 3 sig figs, so I would round my answer for KEQ to 1.34 times 10 to the negative 5.